Hi everybody, we're going to be starting our course and we'll begin with the lesson 1.1 Introduction to Quantitative Reasoning. Make sure you have this handout handy or have it pulled up on your screen and follow along and take good notes. You will see that every lesson that we'll be covering starts with specific objectives. That includes both mathematical objectives as well as quantitative reasoning objectives. Okay, so our course is called Quantitative Reasoning. So what does it mean? Well, the word quantitative implies that we're going to be dealing with something numerical, numbers, and reasoning means thinking. So if you want to put it together, we will be making sense of a situation using numbers. Okay, our course is divided into 5 chapters, and each chapter has lessons that are central around a given theme. You can have a theme on healthcare, there can be a theme on personal finance, or another theme is called citizenship, meaning making sense of the world around you. So let's begin. Let's look at the objectives for this lesson. So by the end of this lesson, students will understand that quantitative reasoning is the ability to understand and use quantitative information. It is a powerful tool in making sense of the world. And relatively simple math can help make sense of more complex situations, as you will see in this lesson. And then more in terms of mathematical objectives that we'll be meeting, is that you'll be able to identify quantitative information in a situation. And then we'll review some of the concepts, so actually you will review it on your own by completing the homework. You'll be rounding numbers, naming the large numbers. Now, since our course is asynchronous, there will be some participation in groups offline. But during these lessons, I will give you some questions, and I'll give you some time to think about the answers and responses, and I will ask you to type up your responses or answer specific multiple choice questions as we go along each lesson. So let's begin. So this lesson has one problem situation, and it starts off with the question, does this information make sense? Alrighty, so let's look at the following situation. You are traveling down the highway and you see a billboard with this message. Every year since 1970, the number of American children living in poverty has doubled. You do not see the name of organization that put up the billboard. So the question is, what groups might have wanted to publish this statement? What are some social issues or political ideas that the statement might support? Alright, so I'll give you a moment to think about those questions and write 2 things down. Okay? Alrighty, so now you got a chance to pinpoint some of the organization perhaps, and let's type them up. So from your list, here are some of the ones that you might have listed. One of them is Children's Defense Fund. That's one of the organization. They're dealing with the poverty, homelessness, specifically in the United States as it pertains to children. One of the other organizations you might heard of is Salvation Army, and it works across the country implementing programs of youth development, disaster relief, elders services, and so on to help the Americans who are in need. Another organization is Save the Children. That's an international organization that specifically child poverty in the United States by focusing on early childhood education outreach, healthy eating and exercise, disaster relief efforts, and child sponsorship opportunities. And maybe I'll list one more, Feeding America. As the name implies, it's about addressing hunger in the United States in particular that provide meals to people in need. One thing that I want you to note in this statement is that we are talking about American children, and we're talking about poverty in the United States. Even though the United States is the most prosperous nation on earth, poverty, hunger, homelessness are real. Now, you might also ask yourself a question is, why would somebody post a billboard, which, as any advertisement, it costs money? What is the purpose of this? Alright, so maybe that comes across the board is that somebody is trying to raise awareness of the importance of this this situation where we want to address poverty among children in the United States. So the information in this statement is called quantitative. Quantitative information uses concept about quantity or number. This can be specific numbers or patterns based on a numerical relationship, such as doubling. So now, looking at this information, if we underline the numerical parts, the quantitative parts, we can see that we're talking about the year 1970. We do see that something is happening every single year. All right, and then you have this mathematical concept of doubling that we'll be also reviewing. Correct? So this is what we're going to address right now. All right, we're going to look at that statement and try to assess, to figure it out, whether this information is reasonable. All right, so looking at the statement itself, every year since 1970, the number of children living in poverty has doubled. Do you think this is reasonable? Does it make sense? Can it be true based on the way the statement is? So I'm giving you a moment and just write down a sentence. What do you think? Is that true? Can it be possibly true? And now what we're going to try to address is specifically, if we only focus on the information in that statement, can we somehow decide if the statement is reasonable by maybe using some mathematical means? Now, both of those questions are more or less open-ended. So after give you again a moment to write down your response for question number 2. What do you think? Alrighty, so let's review. You might have written that yes, it is possible. It is possible since the economy maybe has been fluctuating through the years. Misspelled it. Right? It's going up and down, and therefore there is a poverty has been increasing as well as the economy has been going down at some times since 1970, and as the economy is going down, so as the number of people living in poverty. So that could be true, right? So maybe some of you said that no, since doubling each year appears to be too fast. What I'm trying to say is that doubling itself means that something is increasing pretty rapidly. So it might be way too fast because it's happening every year. All right, so again, this is an open-ended question, so we can't address it, we can't say yes or no for sure until we can back it up. So how do we back it up? Well, we need quantitative information, and that's where we think about how can we assess it. All right, well, we can use mathematics now and our number sense to try to see what's going to happen. All right, well, in question number 3, maybe you could suggest what should we do. So maybe one of you is thinking, well, perhaps I can find the number or look it up, the number of how many children were living in poverty in the year 1970 and then go from there. Well, yes, of course we can look it up, and that number is something, right? It can be thousands of children, hundred thousands of children, probably wouldn't say millions. One thing is that we'll keep constantly sort of looking, especially in chapter 1 and module 1, is the size of the United States. United States has a population of, right now, of about 320 million people or so. All right, percentage of them are children. 1970 population was much smaller, so it's some subset of that population. We can look it up, but that's not the point. The point here is, can we decide whether that statement is reasonable and do the math without looking up that number? Just sort of explore the concept of doubling. All right? So what we could do is to think of, all right, what to start? What is the reasonable number to start? So some of you might say, well, let's start with 1,000 children. Well, some of you might say, well, let's start with 100. And that will be perfectly fine. You can start with whatever number and then explore the concept of doubling. Well, we can actually choose, let us choose the lowest counting number. So a counting number is a mathematical term. Counting number is a number that we use to count with, and the smallest counting number that is there is the number 1. You might say, well, that number is very small. That's not true. That in 1970 there were more than just one child that was living in poverty, and I would say, yes, of course it was more than one. However, if we start with the smallest possible number and we ended up with something unreasonable, then it's already going to be unreasonable because we chose the smallest one. However, if we choose something that's larger, then one might argue, well, if I choose something smaller, then maybe then it will become reasonable. So this is a little logical kind of statement. Think about it, and you'll see it as we're going to do some arithmetic right now. You'll see what I mean by the end of that calculations, okay? So for now, we're going to choose the slowest counting number. One child living in poverty is 1970, and we're going to explore what's going to happen. And that's going to be the conclusion of our first lesson. All right, so we're going to start with the one child living in poverty. We're going to put that right here. And then we're going to go ahead and go each decade, and we'll see what's going to be happening up to year 2017. If we like, we can also add the current year, 2021, and see what's going on. That way, we can explore the concept of doubling. All right, so doubling. That's what I would like to do. Now, in order for us to explore this, okay, I'm going to ask you to fill out the table, all right? And we're not going to fill out this table, the one that you see printed out just yet. We're going to try to explore the concept of doubling by going 1 year at a time. Okay, so we're going to year, and then here we're going to put children in poverty. And we're going to explore what's going to happen. I'm using Excel. You're welcome to use Excel as well. Alright, in this class we'll have an opportunity to get some features of Excel. It's not required that you use it for any of our questions. It's just a nice way to keep this all in one place and understand the patterns. Alrighty, so we're going to start with the year 1970. We're going to put one child. Alright, we're going to go 1 year at a time. So we're going to go to the year 1971. Alright, and the way we can, what I would like to do, I would like to do the first 10 years until we reach 1980. And the way we could do this, we can select these two cells, grab the bottom right square, and go all the way to 1980. You see? Instead of typing each number. Alright, now work with me. Let's understand the concept of doubling. Doubling means times 2. Tripling means times 3. Quadrupling means times 4, and so on. Right? So you're doubling, tripling, and so on. Here we're doubling. We're multiplying it by 2. We can take a calculator. We can use Excel. I'm going to ask Excel to take the number from before. You see how it starts with the equal? And then I'm using 1. And I'm going to ask Excel to double this. Alright, so I'm use a little star times 2. Boom. Okay. Alright, so 1971 we have 2 children. That sounds kind of a little unreasonable for now, but maybe the reason it's 1 child. Well, now we got 2. Well, again, we want to explore the arithmetic behind it. I want you to see how the numbers are going to progress. What are we doing next? We're going to take the number from before and we're going to double it again. 4 children. 2 times 2 is 4. Doubling, multiplying it by 2. You can grab your calculator and go with me, and so on. Alright, so you keep doing this. And instead of typing up a formula each time, Excel has a feature that if you grab the bottom right square and just drag it along, it will do it for you. You see what it does? It takes the number from before and it's doubling it. Times 2, times 2, times 2, times 2. So over the course of the decade, we go from 1 to 1,024 children living in poverty. Okay, so here's what we got so far. Alrighty, so let's go ahead and put that in our table. Alright, let me grab the pen. So it's 1,024. Let's go ahead and also round it since we added. Right, so we're rounding. Here we're going to be rounding to the highest magnitude. A magnitude is the number that is. We'll review magnitude, right after we go through the lesson. But what I would like to do is I would like to round to the largest place value here, which is right here. I'm hoping you remember the rounding rules. If the numbers that follows is less than 5, you keep the digit the way it is. If it is 5 or higher, then you round it up. So in this case, we're going to keep it as 1, and we're going to write that in words. 1,000. It's only 1. Alright, now we need to go to 1990. Alrighty, so we go to 1990. Let's go back to Excel. We gotta extend that table. Alright, let's do it one more time. Alright, we're developing a pattern, and we have Excel, so why not? So we're going to go ahead and scroll to 1990. And then I'm going to ask this. There's also a nice feature where you just double click on that bottom right square, and it will fill it up for you. You see? I just double click. Alright, we got that number. Now we can actually put some commas in here. Alright, so that way it can separate the magnitudes. which we'll review in a moment, well, after we fill out that table. But that's where we add the 1990. Here we go. So this is 1,048,576. All right, so let's go ahead. I think I can just copy and paste that inside that table. Let me try this out. It's kind of large here. Yeah, I'll just type it up. So 1,048,000, I think. 48,576. 48,000 and then 576. All right. Okay, looking at the largest magnitude here, which is the largest place value right here, that looks like 6 significant figures right after 1, so that would be 1 million. All right, so now let's go and talk about the kind of pattern that's going on right here. All right, so let's explore this more. Of course, it's okay on Excel. It's not a big deal for us to just extend it and go all the way to the year 2017, 2021, whatever year you want to go. But I also would like to explore some mathematical features here. So here I got the starting value, which is 1. Then I got 1980, it was already 1,024, and 1990 is already 1,048,576. So my question to you, is there a way we can jump right from 1970 to 1980 without actually doing the calculations in between? Meaning, instead of double, 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 can we do it some other way? All right? I'm going to give you a question. Think about this. All right, and now to kind of explore this, we can go ahead and think about where did 1,024 came from in this calculation. Think about this. You started with 1, and then each time you go 1 year, you were doubling, like this, correct? And you were doing this several times until you reached the final result, which ended up being 1,024. All right, let me ask you a question. How many times did you multiply it by 2? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 years multiplied by 2, 10 times. All right, so multiplying 10 times is not the same thing as multiplying it by 10. Because 1 times 10 will be 10, not 1,024. So the repeated multiplication in mathematics and arithmetic has a shortcut, and that shortcut is called write an exponent. So you can write that as 1. 1 is not needed, but what if it weren't 1? What if you started with 10 or 100, as we discussed earlier? Well, then it would be still the same idea. You're going to be multiplying it by 2. I use a little caret symbol. That's what we use on a computer to show an exponent, and use an exponent of 10, like that. 2 to the power of 10. 2 to the power of 10. Let's come back to the to here, and let's even write that out right here. Is that when we got to 1980, we could have gotten an answer by using 1 and multiplying it by 2 to the power of 10. On your calculators, check this out. If you use 2 and you use the exponent button, whether it is a computer calculator or it is whatever, an iPhone calculator, whatever you're using, and you use 2 to the power of 10, it's either XY or caret symbol, then you'll see the answer is going to be 1,024. Alright, as we're going to be using more calculator heavy stuff, I'm going to be using Desmos scientific calculator. That way you could see my calculation clearer. But I think that you're familiar with the exponent button, right? So you know you can see kind of where I'm going with this. All right. So now going here, 1990. So we said, well, the other one was 2 to the power of 10, correct? We can check this out right here. Look, 1, times 2 to the power of 10 gives us 1024. Going down, instead of doing all these calculations times 2 times 2 times 2, that continues, that pattern of multiplying it by 2 continues. So here, okay, we're going to be, starting with 1 and multiply by 2 20 times, because we're starting all the way from the beginning, right? I want to start with the beginning and then go all the way to 1990. Well, that can be computed with one operation, which is 1 times 2 to the power of 20. And that will be 1,148,576. Okay? Alright, so I'm going to use Excel to fill out the rest, but I'm not going to be actually using all the years in between. I'm going to go ahead and put year 2000, and then 2010, 2017, and because it's a year 2021, I'll also put 2021, and we're going to use that same idea. And instead of multiplying it by 2, 2, 2, 2, we're going to use exponents. So here we have 2 to the power of 30. Alright, so that's 30 from the year 17, right? 30 years. Okay. Alright, so for the 2010, right? That's what we had. We're going to use 2 to the power of, how many years is that? From 2070. That's 40 years. Notice we don't have to put 1 anymore because multiplying by 1 doesn't do anything. Alright? So it's just 2 to the power of 40. Whoa! Excel even pushed the column. Alright? So let's do one more. Well, 2 more. So it's here it will be 2 to the power. Make sure you check this on your calculators. So that would be 2 to the power of 47 years. Whoa! And finally, the last one is 2 to the power of 51. Is that correct? That's from 2017 to 2021. That's 51 years. And here's what we got. Alright, let's go ahead and round them and name them. So this one right here, okay, has 3, 6, 9 periods. That's how they call those 3 digits separated with a comma. They call periods. So this one right here was a million. A million has 2 periods, which is 6 digit right after 1 digits, not zeros but 6 numbers. This one has 3 periods. Each one is 3 digits, so it's 9 digits. 9 digit number, it's not 9 digit number, it's 1 followed by 9 digits, which making it a 10 digit number, is in billions. So this is 1 billion. Alright, the next one is 3, 6, 9, 12. 4 periods, 12 digits, so that is in trillions. Next one is 3, 6, 9, 12, still trillions, so let's round this into 140. And after that, 3, 6, 9, 12, and then 15. I'm going to give you an extra credit if you find what that is. It's 2 something, I don't know, quintillions? I don't know what the word is because it's not used much in quantitative reasoning. We usually don't go higher than a trillion. So it's 2 something. Alright? Go ahead and figure it out and, I'll give you a little point for that. Alrighty, but now going back into understanding what happened. The question asks us whether that statement was reasonable. Well, if it were reasonable, then multiplying it by 2, alright, will produce numbers that make sense. Well, having 140 trillion children living in poverty in 2017 cannot be possible. Why not? Well, because population of the United States is measured in millions, is about 320 million people. People, not children, people altogether. And 140 trillion is a much larger number than that. So it's not reasonable. And we start with one child. If we were to start with any number that's larger than that, then we'll end up with even higher number. So that statement is not reasonable because we're getting something that does not make sense. So you see how we had a simple mathematics multiplying by 2 where we were able to assess that statement and said that there's something wrong with that statement. Alright? So let me give you a moment and ask you, can you reword this statement in a way that it would make sense? So what piece here, what information here is bad? Or what made this not work? Because the poverty is real, and yes, the number of children living in poverty did increase, for sure. Population has gone up. So can you perhaps reword that statement that will be reasonable? Let me give you a moment to write that statement. All right, so what's the reworded statement? Well, instead of saying every year, if you say that since, so if you get rid of the word every year and just say since 1970 the number of American children living in poverty has doubled one time. Doubled one time. That's it. You don't need to write one time. Just get rid of the word every year. Just remove it. Okay, so just remove this. And then it would make sense. I mean, it just doubled one time. So there were, several thousands of children living in poverty in 1970. So that number got multiplied by 2 one time. And that would possibly make sense. Alrighty, and that concludes the first lesson.